anything in particular in that grouping that we looked at yesterday you guys want to check? Everything's hunky-dory. Yes, ma'am. Hi. Okay. So there was no problemos. Good old completing the square. What's that?
You give like review problems?
Yeah. Yep. So in this case here, they're asking, guys, we got a bunch of stuff I want to go through with you guys today, so let's try and keep this down a little bit here. This one here, it asks that you complete the square. Now remember, the best time to complete the square is when your first term is 1, or your A value is 1, excuse me, and your B value is always even. That's the best time to complete the square. If your first term is 1 and your B value is odd, use quadratic formula, unless you can factor it. Okay? So I would jump right away. Obviously, they're setting it up for you. So you have your x squared plus 4x plus blah is 3 plus blah. Okay? Now, the reason why we have to put that blah on both sides is because we're going to add something to both sides of the equation to make sure that everything stays equal. So our process was take half of b, well, what's half of 4? 2. We drop it into the parentheses, square it, and add it to both sides. So there's our complete square process, and then it's really, really fast. All you have to do is take the square root of both sides. We get x plus 2 is plus or minus root 7. Don't forget plus or minuses. Shift-key is going to do push-ups for every time you forget a plus minus. Wait, that's not a good idea, because then you guys all forget plus minuses, and force shift-key to get huge. So your answer would be yeah. Or how about this? Every time you do put the plus minus in the right spot, shift-key does push-ups. I'm messing with you. Okay, and that's what that would look like. Does that ring a bell now? Yes, ma'am. Yeah, absolutely. When I would factor, if I'm going to go ahead and just factor, I'm going to go and I'm going to look at and see. Well, first of all, is there a GCF? Remember on the quiz we had one where it was I think it was like 3x squared, 30 and a 15 maybe or something along those lines. I would always look for GCFs first, and then I would see, if you have your ax squared plus bx plus c, I would check and see what multiplies to my tails that adds to the middle. So if I can figure out what a times c is that adds to b, if I can find that quickly, I'm just going to go ahead and factor. If not, then I fall to one of the other setups. So if it's not a quick thing to factor, which usually by now you guys are like, oh, okay, this is what times what's 12 that you add together to get 7, 4 and 3, things like that. You pick up on that over time. Now, if it winds up being something for completing the square, if you're going to complete the square, then I would look to make sure that my a value is 1 and b is even. I would do that. Now, it doesn't mean that you can't complete the square if your a value is not 1. It's just you have to be a little bit more cautious with it when you have to distribute out the other side. Excuse me, carrots are going to kill me apparently. I got to stop. Let's just start eating potato chips all day long. And, yeah. And then I would fall back to the quadratic formula. Well, I'll say this. Now, So, and the quadratic formula and all that kind of stuff still works, even when you have the word problems or if you have other styles. It just was a little bit more cumbersome to do that. When I would do the other things, the word problems, that's when depending on the format. Does that help with those?
Yeah.
Cool. Yes, ma'am. Oh. Yes, sir. Excuse me. That was the one that we learned from. Oh, sorry, that's a different one. So when you have vertex, that means you're using the vertex form. So you're going to rewrite the equation in a vertex form. Vertex form was y equals a x minus h quantity squared plus k. Well, here they're telling you your vertex is your hk, and then the points are x and y. Substitute all in and solve for, and just rewrite. You did 33 on the other page, on the next page, didn't you? You did that 33? Yeah. Well, it's the same problem. I can show you how to do it. It's the same thing. I can walk through it. It's not a problem. Same deal. So y equals a x minus h quantity squared plus k. So you get negative 18 is a, negative 1 plus 3 quantity squared plus 2. So let's see here. We get 2 squared, so we get 4. So 4a is going to equal negative 20. So a is negative 5. Now I know what my a value is, and I just rewrite it out. So your answer would have been then y equals negative 5 x plus 3 quantity squared plus 2. And that would have been your final answer. More often than not, what people mess up here is look how many negative values you have. E5 S7. Yes, sir. I just moved it over right. I tend to skip steps. I apologize. That's not used to today. What else do you want to look at, guys? Yeah, bless you. Yes, ma'am. Yeah, when you find the discriminant, it depends if I ask you it. Remember, the discriminant just helps you, it's just the junk underneath the radical. So it's just the b squared minus 4ac. The discriminant is some number. And if that number is positive, 2 real answers. If it is negative, 2 imaginary answers. And if it is equal to 0, you have 1 answer, 1 real answer. That's all the discriminant helps you define. I would keep this in the chapter. I see where you're going with that, but yeah. But remember, if you get a discriminant, if you get your b squared minus 4ac equal to 0, that just means that your graph itself touches it at one spot. And I see where you're going with you take, because what happens then you get your opposite of b over 2a, which is the axis of symmetry, which means that has to be the value. That's all it is. We'll talk more about why that occurs when we get to the actual polynomials. About the whole thing with the 2 negative, or excuse me, when it's negative, you have 2 imaginary solutions. Because whenever you have 1 imaginary solution, you have to have the negative version of it, or if you have the negative, you have to have the positive, because they always come in pairs. Yes, square roots, things, stuff. I'm doing it right now. Try really hard, you can do it too. Good job, you're fine. Don't worry about graphing imaginaries. You'll do that in pre-calc. Yes, ma'am. Okay, imaginary numbers. Remember, imaginary numbers, we take the square root of some negative value. When you take the square root of a negative, remember, numbers can be written as composites. So you got the square root of -1 and the square root of 30. And then 30 doesn't have a perfect square root, doesn't it? So my answer would have been I root 30. Now, as far as the other versions of imaginary numbers, remember how I showed you you could do that? Where if you had why would I make you do that by hand? Am I right? Same idea. It's like, why would I make you do this by hand now from now on? There's really no valid reason to. Because it'll do it for us. You know what I mean? So as long as you know how to simplify square roots, if they have imaginaries in them, it'll be fine. I wouldn't worry. Okay? Oh, okay. There's a button. It's the second. Calculator. Yes, there's calculator, non-calculator. The non-calculator, or I should say the non-graphing calculator portion will be anything with factoring, really, because in all honesty, I mean, I could give you all imaginary graphing, which you couldn't find on a calculator, but what fun is that? So if I mix it up a little bit and give you some that have real values and non-reals and all, I would rather not have the graphing calculator accessible, but then I would have the graphing calculator accessible for when it goes to the word problems and other things that we could do, because that's what we did throughout the class. I won't ever spring stuff on you guys that if you're accustomed to doing a specific style problem with the calculator and take it away. Okay? That's just, there's no reason, rationale for that at all. Yeah. No, because we didn't do we haven't done any graphing for a while. And the reason I don't go back to the graphing of all this stuff is because can you look at one of the equations and give me the information? Can you tell me what the axis of symmetry is? Can you tell me what the vertex is? Can you tell me the direction? Without having to graph all that. Because in parts of it, aren't you really doing that kind of anyway? You're dissecting the parts of it to know how to do it. And that means I think that's more valid than just saying, I can just make a table and just plug and chug the values. Because you can do that too, and kind of fudge your way through if you had to. And there's nothing wrong with it. I look for the deeper, more intense awesomeness of meaning of things. What else we got? Yes, ma'am. Maybe. You'd have to have a calculator for it, wouldn't you? Unless I give you one that had the y-intercept at your c value. You had one in your homework class. I think it was 35, I want to say. Let me look for that real quick. I'll do it next. If you go back to your homework from last night, it didn't. But I thought you were talking about one that did have 0 or did not have 0. What? The matrix one. Well, if you look at 35, is setting you up to use the matrix. Guys, take your x squared minus, so it's x squared a minus xb plus c is y. No, x is negative. So 16a minus 4b plus 1c is -2. And then you get, these 9s keep coming back here. 9, 3, 1. So what I'm doing there is I'm taking the standard form ax squared bx and c. I'm taking x squared x and substituting all those values in. I take that and I create that what's called a coefficient matrix. Oops. My coefficient matrix of this would be 25, -5, 1, 16, -4, 1, negative 1 power, and I multiply that then to, he's still in the box. I know it! He's in a box. Blue box. And I just basically throw that in the calculator just like that. It'll spit out my answer as a column matrix, and that's my A, B, and C value, and I just write down the equation. Does that help? If it does have a 0, good question again. Hey guys, if it does have a 0, it gives you that y-intercept. That means you know what your C value is. If you know what your C value is, then you know how to substitute it here and here, and then all of a sudden you have 2 equations, and you can solve that with just a regular calculator. It's a little bit easier without a 0, isn't it? All right? Not terrible? Okay. So what I did was, on the calendar, I put up 2 separate documents. I did one where it's kind of generic, where it's just some review stuff. It's got examples of factoring and quadratic formula. It's got complete squares, square rooting things. It's a mixture of real, non-real answers and whatnot. It's got all solution stuff there too for it. So there's a bunch of questions like that thrown up there right now. As well as I posted up, I went through my files of word problem things again. And I just kind of cut and pasted the sheet together and posted that PDF file as well. So what I want to do here real quick, I'm sorry, great to answer your question. What do you got? Yeah, it's right on my desk. There's a solution manual. So have you given me the paperback solution manual on the right here, please? Help, yeah. Anytime you ever want to look at the solution manual, it's always back on the desk. Help yourself. Okay. So just real quick, to remind you guys of how this stuff works, I'm gonna walk you through one of these real fast. I'll do this one. Yes, sir. Oh, thank you, Verify for help. Yeah, Alpha Zoom. So this is a style problem that obviously you'd have to have a calculator with. Okay, and I want to remind you what values of things work. So in this case here, it's given you, and if you have your Chromebook, you want to pull this up on the calendar. I didn't print this out, so it's all right there for you. The formula gives the height of an object thrown from a building 160 feet, fly with an initial speed of 48 feet per second, where time is measured in seconds. Find the time for the object to hit the ground and find the maximum height of the object. Now remember, a picture like this was like you were standing on top of something, and you throw it in the air, and it hits the ground, and it explodes, and it dies. Okay? You know that it's given you a C value in this case, because it's written in standard form. It tells you your initial height. How high up are you to start with? You're starting at a height of 160 feet. So that tells you that the y-axis is your height, and your x-axis is then time. Okay? That's where that's going from. Now, what it's asking you to do then is figure out how long did it asks, find the time it hits the ground, so how long did it take to get to here, and then how high was this spot, okay? Or it could ask you at what time did it hit its maximum, and so on and so on. It's just a matter of manipulating and understanding what the question is asking. So this is the style that you go directly to your calculator. Go to your y equals, and put in that negative 16. Out. You can, and that'll get your maximum, but not every time it's asking you for the axis of symmetry for that. But that would help you to get that value. Sometimes it might ask you, because this was asking for a 0 for when it hit the ground. But by all means, what happens if the numbers really suck? Yeah, throw in the calculator. Well, there's nothing wrong with that. Go for it. Was it negative 16x squared? Was it plus 48? And then it was plus 160. Thank you, guys. Oh, thank you. Would have done goofed the whole thing up. Now, I know right off the bat that I'm going to want to look at this graphically so I can hit my calculate zoom or calculate maximum and all that. what should I probably change my minimum height requirement to? Probably around 200-ish and see if it looks. See if I can see it, because I know that it's going to be at least at 160, but it's going to go up farther than that. So I'm maybe 200, 250. So I'm going to go to my window and automatically change it to 200. And now I'll hit graph and see if it shows up. Yay! Okay. So from here, if I want to first find out what the maximum height was, I hit second and calculate maximum. And then you just have to move my boundaries left and right a bit. So remember, moving your left boundary would be to the left of what appears as though to be the maximum. Hit enter. Move to the right of it. Hit enter again, and hit guess. And basically, yeah, I don't know what it means. Do you know what it means on these stuff there? I guess that your guess could be a guess of guess right, but I don't know.
It's like that can change it.
I know. It's purple. So my maximum height is at 196, and I would say that it occurred after a second and a half. When you see 1.49999, do you guys agree that's 1.5 seconds? Shut up. All right, so that's what that would look like. And then, obviously, for the last part to calculate your zero, you can do one of two things. You can quickly check and see in your table if you get a zero. In this case, we do. I have a zero at 5 seconds. If you don't see a zero at 5, which means it's not an integer value, you'd have to use your calculate zero, and it could be at like 4.5 seconds or 8 seconds, whatever. You might have to move around. But it's really, really easy to tell where it would occur because it jumps between positive and negative. So if that happens, you know how to zoom in or not zoom in, excuse me, but hit that second calculate zero. Does that make sense? Huh? What was the question? Where it hit the ground? And remember, when it hits the ground, it means how much time has elapsed. So that's our. There you go. So there's your 5-second rule. That was. Hey, you know what? Spaceballs was on last night. It was great. Spaceballs was great. I was laughing so hard, my wife looked at me. She said, "What are you, 12?" And I said, "Yes. Yes, I am." All right. Let's try another one. Oh, that's the wrong one. Ludicrous speed. They've gone plaid. It's great. Yes. All right. The length of a ping pong table is 3 feet more than twice the width. The area of a ping pong table is 90 square feet. Well, aren't ping pong tables rectangular? It's really quick to have a 90 square foot ping pong table. Now, think about it in real generic terms. 90 square feet is just 9 by 10. That's huge, but that's a really big ping pong table. That's bigger than a sheet of drywall. That's like 2 sheets of drywall. What? Drywall. All right. Most walls in your houses are drywall. With stuff that you have paint on. It's drywall. Obviously, in buildings like this, you use concrete or cinder block. In homes, you use drywall. Bathrooms, you use green board. Cement board, they use wood tile. You've seen drywall. It's those big sheets of 4x8 sheets of white stuff at Lowe's and Menards and all that. Anyway, so how do you find the area of a rectangle? Length times width. So, what does the word is mean in math? equal. So if it says the length is 3 feet more and twice the width. So you just use, you're basically creating a system of equations with substitution into a quadratic. So I know that my length, I would put here. So the area, which was 90, is going to equal, actually, here. 90 is going to equal, well, the width times 3 plus 2 width, otherwise known as, slide this up, 0 equals 2 width squared plus 3 width minus 90. I get that. Once again, as we were talking, like you were asking a second ago, how do I know what to set up with this problem? Well, in my mind, yes, sir. Yeah. In my mind, I'm sitting here going, there's no way I'm going to want to try and figure out what times what's negative 180 to add 3. So I also am thinking that if I throw it in my calculator real quick, I'm going to check my table and see if I get a 0 at an integer. If I get a 0 at an integer, quick, great, super fast. If not, I might have to use a calculator. Okay. Since I have a calculator, I'm just going to put that in at, what was it, 2x squared plus 3x minus 90. Thank you. I'm going to go right to my table. Where do I get a 0? 6. I'm going to have another 0 at a negative value, but can I have negative dimensions? Yeah. That's good. So my answer, my width would have to equal 6. If my width is 6, what's the length? There you go. 6 foot by 15. It seems really big.
It is.
Because these are 8. These are 18. So there's 1, 2, 3, 4, 5, 6. I mean, that's probably about right.
Yeah.
6 feet? No, that seems about right. I mean, because this, my wingspan is almost 7 foot. So, I mean, you start thinking about the width here, if I bring it in, that's around 6 foot right here. It just sounds, because, you know, it's not every day you go out there trying to measure out your ping pong tables, and you don't have the times. Is there Olympic ping pong versus professional ping pong versus basement ping pong? Could we have kitty tabletop ping pong? I'm gonna see how long I keep her arm up in the air. Anybody else? Yes, ma'am. Randomly. They're all, but you know what? They're all about the same. They really are. They really are. Everything we looked at, they're all about the same. Okay. Also, remember, when you think about when we did the cost ones, you had price and units. Remember how we did price and units together gives you total revenue? Okay. Remember, when you see stuff like that, hey guys, when you see stuff like that, and we were just talking about that in Flex, was that dependent upon the style of problem, you have to read it cautiously. These problems are awesome because you're able to figure out zeros, calculate your axis of symmetry for your x value, and that will help generate a maximum. That maximum is always that total revenue. The x value is just your multiplier. How many times you have to raise the price? How many times you have to decrease the price? How many more things would you sell versus how many more things would you? How many less things you could sell? Okay, that's where the correlation for those values work. Cost unit problems should be the fastest ones to look at because it's quite literally draw out horizontally, find the middle, and go from there. Okay? Also, these things goes right in your calculator. You can figure it out too. It's just a matter of understanding what the values mean. Okay? What else you got? Devin, you got a question? How did you get out of that box? You stood up. Proud of you. You overcame adversity. Verify. Dude, where's verify? There you go. See you, Devin. I'll have that stuff emailed out for tomorrow, okay? Well, not to you, but, you know. Yeah, my people email your people, and we'll have lunch. What else do we look at? What's that? Yeah, test is on paper. Very good. I'm sorry. A lot of times to review things, it's kind of hard to find everything because we've done so much. Anything we've done is fair game, but I will tell you, I'm not going to have you simplify, 2 plus 3i over, 3 minus 2i. I'm not going to make you do that. Because you just press a button. What's that? Right. There's no reason to be able to have to do that. Second decimal. So there's no reason for me to have to do that. I mean, you still have, like I was saying earlier, you still have to know how to do this. You know what I mean? You can't simplify it. You can't do it in terms like that. Yes, you can do the square root of 45, right? It'd be I root 45. It'd give you 3I root 5, I believe. And if it was over an equal sign, I'd make sure the plus was. What else we got? Yeah. See if I have one laying around. Oh, where did it go? Oh, there it is. Ladies and gentlemen, there's a question I'm trying to find for people, so please hold on. Let's not any of that. Let's see. Oh, here's the one from the quiz. Going to go over that one real quick. You may do that one again. So here's that. Here's the same cost question we did on the quiz. Just for a quick reminder on how that works. When you have cost problems, remember you've got two things. You have price. This is the quiz one. You have price and you have units. In this case, we're selling memberships. Okay. So if you've got a price of $300, you have then 1,000 members. Okay. So in your mind, right off the bat, is that if you just sold it for $300, you're gonna your revenue then would be what? 300,000, is that right? Yeah. It'd be $300,000 would be your total revenue because you just multiply that out. Okay. Now it says for each increase of $2, you expect to lose 5 people. Now that means that that multiplier of 2, this just means if I increase it one time, it goes up to $302. If I increase it twice, it goes up to $304, and so on and so on. Okay. So this allows you that this still gives you total revenue. Now, when you're in intercept form, you can calculate your axis of symmetry right away. You know that you have zeros. Set them both equal to 0, you get one at negative 150, and the other one would be at 200. Okay? Just by setting your two terms equal to 0. From there, I get the midpoint. Well, 200 and a negative 150 is 50, and half of that is at 25. So the x value equaling 25 would generate your maximum. Okay? So if I increase it 25 times, I will get my biggest bang for my buck. That's what that means. This means that value of x stands for the multiplier of how many times you increase it and how many, in this case, how many fewer units you will sell. Sometimes it's decrease in price, increase in units, but that multiplier, that value of x, is what that stands for. So by putting this into the equation, then, you will generate that new revenue. I think we just did this. What was it, 302 something? Yeah, right? So it was like 320,000 something, something, something. I forgot what the answer was on that. But that's where we generated total revenue. Most of you guys screwed up and just said 25 for your price. Okay? Or you substituted in the wrong spot. But remember, the original price then, the price at which you get the biggest bang for your buck would be 300 times, or 300 plus 50. So at $350, you're going to then sell, let's see, 1,000 minus 125 is what? 875? Yes. You'll have 875 members. So that's what that value of X allows you to figure out. It allows you to figure out pricing and how many people will be at that price. You put them together to get your total revenue. Yes, ma'am. Yes, ma'am. Because that would maximize your total revenue. That will give you the most revenue. All right. Does that help? That's what that means. Is that little piece of value? It substitutes back and forth like that. Okay. What else we got? You again? No. Yes, there's words and there are problems. Yes. I don't know how many there are. Sure. Yes. Whatever. Yes. I believe I've answered that question. Were you speaking again? Oh, Miss Mitchell, I'm messing with you. Yes. Yeah, remember, with the word problem stuff that we have, I could easily give you one like this without the graphing calculator, because you don't really need it, at all to do that. But I know that there's one of the strategies to be able to do that is that I haven't taken the graphing calculator away from you to do a problem like that, so I'm not going to do that on your test. I'm a jerk, but I'm not that big of a jerk. Why some of you should be. We all right? There's those problems that are posted on the web. By all means, take a look at them. Swing by tomorrow morning if you got questions. I'll be in here just like normal. See how we do, okay? That work one? I can't find it anymore. I didn't look at it. For some odd reason, I must have created something and I just never gave it back. I just didn't write it down.